is running out to witness one of the most extraordinary discoveries of 2025, Comet 3 I/ATLAS, only the third interstellar visitor ever recorded. Hubble just gave us its sharpest view yet, revealing a dusty cocoon and faint tail trailing a comet older than our solar system, hurtling through space at 130,000 miles per hour. But here's the real fireworks. Scientists are now spotting a bizarre planetary alignment in its trajectory. Mars, Jupiter, and even Earth's path are lining up in ways that defy our expectations. What's causing this cosmic choreography? Is it just chance or something deeper, something no one anticipated? Stick with me, because 3 I/ATLAS isn't just passing through, it's rewriting the rules. What is 3 I/ATLAS and why it matters? Comet 3 I/ATLAS is only the third confirmed interstellar object ever discovered, following Oumuamua in 2017 and 2 I/Borisov in 2019. It was first spotted on July 1st, 2025 by the ATLAS telescope in Chile, and its trajectory was immediately flagged as unbound to our sun, meaning it came from beyond our solar system. What makes it especially fascinating is that scientists now believe 3 I/ATLAS may be older than our entire solar system, possibly over 7 billion years old. Its origin is likely the Milky Way's thick disk, a region of ancient stars that date back much earlier than our sun. Thanks to the Hubble Space Telescope, astronomers have captured the clearest images yet, showing a teardrop-shaped plume and a faint dust trail, and refining estimates of its size, anywhere between 320 meters to 5.6 kilometers across. It's likely the largest interstellar visitor observed to date, because it's both bright and fast-moving. 3 I/ATLAS represents an unprecedented opportunity. Its hyperbolic trajectory, speed, and scale make it an ideal probe into the chemistry and physics of distant star systems. In effect, studying it is like holding a tangible piece of someone else's cosmic neighborhood. New discovery, planetary alignment, and unusual behavior. Comet 3 I/ATLAS isn't just any interstellar visitor. It's drawing attention for how its path intersects our solar system with uncanny precision. Recent observations show that 3 I/ATLAS will pass remarkably close to Mars, Venus, and Jupiter over the next several months, all while following an unusually flat trajectory within just 5 degrees of the solar system's orbital plane. Astronomer Avi Loeb and his colleagues have even proposed that such a rare alignment has less than a 0.005% chance of occurring randomly, raising the question, is this cosmic coincidence or something else entirely? Meanwhile, NASA's Hubble telescope has captured the most detailed images yet of 3 I/Atlas, revealing a teardrop-shaped dust plume, a faint tail, and helping refine size estimates to anywhere between 320 meters and 5.6 kilometers, still the largest interstellar object observed to date. Taken together, these discoveries paint a picture of a comet that's not only ancient and fast, but also moving with a trajectory that defies expectations and challenging how we think interstellar objects treat planetary orbits. Water detected, uncommon at this distance. If there's one thing that makes 3 I/ATLAS even more extraordinary, it's water. Not just ice in its nucleus, but actual outgassing, detected far from the sun, beyond 3 astronomical units where solar heat is weak. That's highly unusual. Spectroscopic data from observatories like IRTF and TESS have revealed a distinct water vapor signal emerging from 3 I/ATLAS. Normally, comets only release gas this far out when they're larger or orbiting much closer to the sun. Seeing 3 I/ATLAS behave this way suggests it has an active surface, maybe covered in volatile ices or generously releasing particles with every solar pass. Its activity level is comparable to or exceeding comets we see near perihelion, yet it's still far from the sun. This isn't just a quirk. If confirmed, it signals that 3 I/ATLAS has retained primordial volatiles despite its interstellar journey. Its surface may be rich, its structure porous. Whatever it is, what makes it truly rare is that we're watching it display comet-like behavior far beyond where we expect such behavior to occur. In short, water vapor from an interstellar visitor at this distance is both remarkable and potentially game-changing, and it raises a crucial question. Is 3 I/ATLAS providing a glimpse into the icy worlds drifting between star systems, or is it something even more extraordinary? What it's made of, dust, ice, or something more? Scientists now have one big question. What exactly is 3 I/ATLAS made of? Spectral readings from the Hubble Space Telescope and ground-based observatories have revealed a complex signature, strong evidence of dust and water ice, but also unidentified compounds that don't neatly match known solar system comets. The dust appears fine-grained, suggesting it hasn't been compacted by countless close passes around a star. That makes sense for an object believed to be around 7 billion years old, possibly older than our own solar system. The ice content also appears unusually pure, with fewer of the organic contaminants we typically see in local comets. This could mean it formed in an extremely cold, distant region of its home star system, or in a completely different kind of stellar nursery. But here's where it gets interesting. There are faint absorption features in the spectrum that some researchers think could indicate complex organics or exotic ices, like nitrogen or carbon monoxide. These are rare and volatile, and spotting them this far from the Sun is a big deal. If confirmed, 3I/ATLAS could be more than just a frozen relic. It might be carrying the raw materials that could seed life on planets, and because it's interstellar, those materials wouldn't be from our Sun's family. They'd be from another star entirely. In other words, every reading we take from this comet is like peeking into the chemistry set of an alien solar system. Speculative theories versus scientific reality. Whenever a strange cosmic event happens, especially one involving an interstellar visitor, speculation spreads fast. In the case of 3I/ATLAS, some online forums are already buzzing with theories that the comet's unusual trajectory is artificial, that the alignment is part of a hidden planetary system, or even that it's a probe from an advanced civilization. These ideas make for fascinating headlines, but so far, there's no hard evidence to support them. Scientists stress that while the alignment looks unusual from our perspective, it can still be explained through celestial mechanics. Objects traveling through the solar system often appear to line up with planets simply due to timing and orbital geometry, especially when viewed from Earth's moving vantage point. The key difference between speculation and science is testability. Researchers at NASA, ESA, and multiple observatories are focusing on data they can measure: the comet's speed, rotation, composition, and gravitational interactions. These hard facts will reveal whether the alignment is a meaningful physical phenomenon or just an eye-catching coincidence. Still, scientists aren't dismissing the mystery outright. They acknowledge that 3I/ATLAS has already defied some expectations, and that means the door is open for new insights. But until the numbers point somewhere truly extraordinary, the official position remains clear. Remarkable claims require remarkable evidence. Why it's a big deal for astronomy. Every time an interstellar object passes through our solar system, it's like getting a postcard from another part of the galaxy, a rare chance to study material that was formed under completely different conditions than our Sun and planets. 3I/ATLAS isn't just any comet, it's the third confirmed interstellar visitor in history, and it's giving scientists data they can't get anywhere else. Its unusual alignment with planets is an extra twist, offering a chance to test how such visitors interact gravitationally with our solar system in real time. Observing these effects helps refine our models of orbital mechanics and even gives clues about how planetary systems, including our own, form and evolve. And because 3I/ATLAS appears to be billions of years old, possibly older than our solar system itself, every measurement of its composition, structure, and trajectory is like opening a time capsule from the early galaxy. For astronomers, it's a reminder that our solar system is not isolated. We're part of a much larger, dynamic cosmic neighborhood, and sometimes the neighbors drop by. What's next and how to watch? Comet 3I/ATLAS won't be hanging around forever. Astronomers estimate that the optimal observation window will close within just a few months before it continues its long journey back into deep interstellar space, possibly never to return. NASA, ESA, and observatories around the world are scheduling dedicated viewing sessions to track its unusual path and gather every bit of data before it's gone. Professional telescopes will capture high-resolution images and spectra, but amateur astronomers with strong backyard setups can also join in, especially during its brightest approach. If you want to follow along, keep an eye on NASA's official updates, the European Space Agency's planetary defense bulletins, and astronomy tracking apps like Sky Safari or Stellarium, which will list precise viewing times for your location. For scientists, this is a once-in-a-lifetime research opportunity. For the rest of us, it's a rare cosmic show, a reminder that our solar system is just one stop in the vast, ever-changing highway of the galaxy.